Thank you everybody for joining. This is the last workshop that we created here at G&L for 2024. We are talking about MoQ media over Quic deep dive, and I'm very happy that we have so many people registered for this call here. It will be recorded, so you can get a recording after it. Let me just skip over here to the next slide. I'm happy to welcome you here, and this is an overview of the speakers that we have today. We have, again, Will Law from Akamai, we have Mike English from IDEAS, we have myself and Tobias Drees, also from G&L. The agenda that we want to share with you today is I will have a quick overview of our 24 streaming tech. I will then hand over to Tobias, who will tell us what's wrong with that, why we need something else. We are then handing over to Mike and Will. They will telling us how MoQ is trying to solve this. This will be distributed by Mike telling us the basics of it, and then Will talking about current developments and outlook. We will then have a couple of demos, and there is a Q&A session. As we have a lot of content, we might have to skip this after the hour, so we will definitely answer questions, but not possibly while we're doing everything within the hour that this was planned for. So happy to see you here. Let's start with the 24 streaming tech stack that we observe here. What we see is that everything boils down to practically three main modes of communications in streaming. The first one is a passive consumption mode, which is when people just receive content but have no opportunity or intention to have some interaction with it. Latency tolerance is high. Everything can be 45 seconds or 60 seconds. Everything is okay. Also like in video on demand, where you have practically unlimited latency. That's okay, and you don't see any real business value in getting lower than 20 seconds, for instance. And you can see that by notices that here Dan Rayburn told about the Super Bowl in 2022. Everybody was complaining there is no ultra low latency stream. But why is that? Because there was no real business value in creating that, and it all comes with some issues or with some challenges, and it's not worth it for some kinds of content here. The other group is the influential or interactive consumption mode, where in some way viewers engage with the content in ways where you influence what is going on in front of the camera, or where you have interactions with tightly coupled elements like placing bets or polling or reactions or something like that. And even in cases where you have to control just the technical control of the incoming video. So if you have a control that is working for passive consumption, but you want to see what's going on in real time, then you need some influential or interactive live mode here. This typically should be below 5 seconds for interaction, but if it's not real-time communication, it does not need to be lower than 500 milliseconds. So there are a couple of things that you can do well with 5 seconds, 6 seconds, but there is no need to go below 500 milliseconds. For real-time communication, you should be below 500 or 450 milliseconds. The lower the better, but that is usually the time that people accept here. This is not coming from just simple thought. This is being done in a lot of examinations about cognition and communication talks. And you see here from the ITU G114 standard, mouth-to-ear delay versus user satisfaction. And you see here the user satisfaction on the vertical axis, and it's high unless you are below 200 milliseconds. After 200 milliseconds, it quickly drops. And so 400, 450 to 500 leaves some users dissatisfied, many users dissatisfied. So this is what is usually acceptable, where you can start to work, because continuously providing 200 milliseconds is very hard. So our tech stack where we work with that, so for the passive consumption mode, we have HLS and Dash. We have still Icecast and MPEG-TS over TCP. For the influential consumption mode, we have low latency HLS and low latency Dash. There is ESP, alternative approach, which comes with additional license costs. Then there's WebRTC, which can of course cover this mode here. And we have, for the real-time communication mode, practically only WebRTC currently, which is the basis of most of the video conferencing tools that we are using, and also of specialized service providers that just specialize in real-time communication. There are some additions that come with it that work around network address translation, like stun and turn. We have WIP and web, which are bridging over to HTTP ingest and egress, but that's practically it. Why do we still have Icecast and MPEG-TS over TCP? That is because customers are demanding it. We still have 1 million concurrent radio listeners every morning. It's like the vinyl of streaming on G&L's side. It's that simple. Devices just work with it. It plays practically everywhere. And so people demand it because we have so many old devices in the place anywhere. MPEG-TS is necessary because we have a lot of HbbTV devices that don't support Dash because they are older than version 1.5. So this is also necessary to support these old devices. And we expect them to be there for a couple of more years. So now I would like to start a quick poll about how many streaming protocols you are working with. So Jin-Soon will now open another poll that you can open and that you can see and answer, and we'd be interested to see the results later on. In the meantime, I'm talking about the distribution versus contribution field. So let me check, that was the wrong button here. Okay, so for the passive and influential communication mode, we usually distinguish between contribution, where we have a high quality signal coming from a source to a further processing device or service in a very controlled environment. Higher bit rates come and have more details so that we can compress them down the line. This usually comes with mostly protocols like SRT, RISC, ZXI. There also is some RTMP, especially with the enhanced RTMP standard that has been recently released. And we still have a lot of MPEG-TS over UDP. That's mainly the contribution protocols that we work with. In the distribution side, where you have compressed content for mass consumption, we have the different protocols that we already covered. For real-time communication, practically ingest is egress is WebRTC, unless you have, let me check back, unless you have the optimizations for HTTP ingest. So let me also answer my question here on the poll, and let's close it. So do we see the results somewhere? We can show them later otherwise. There are the results. Okay, so 6 or more protocols is answered by 31% of all people. So that means a third of the audience uses 6 or more protocols, and only 3% are using 1 or 0. So that's a tiny amount, and you see that a lot of protocols are being in use. Thank you for answering that. Okay, I will now hand over to Tobias. Before I just show a quick overview here of the global global distribution of latency. So we have here data centers, and this is data from Azure because they have published all this information for round trip time values in milliseconds. If I just use data centers in Germany and then look at the tables that they provide, these are the average round trip times in milliseconds between their Asian data centers to Germany, which is 217 milliseconds, Middle East 111, Australia 290, intra-Europe 20, North America to Germany 130, South America 200, and Africa 160. So those are just what the reality shows, what the milliseconds are that we have between different remote points under the control of a single entity, in this case Microsoft with Azure. So this is like a natural law that you see in the distribution over the networks here in the world. Okay, so that ends my part, and I will hand over to Tobias now. And Tobias will talk about what's wrong with the current tech stack. Tobias, I hand over to you.
Thank you, Alexander. Yeah, I will just rush you really quickly through the problems that we still see with the current streaming protocols that we have in place today, and why we might need something new. The first of all, it's latency. So the introduction of HLS and Dash, they gave us really the ability to deliver media at really large scales, but that came at the cost of latency, of course. On the other hand, WebRTC, protocols like WebRTC, they provide us with very low latency that make, so you can have real-time interactions. But the cacheability of these streaming formats is not really there. So they were lacking really the sweet spot where we can have low latency with the scalability of cached content, right? So the next one is head of line blocking. A very simple analogy would be myself in this webinar here. I'm blocking the line now for you to hear interesting stuff from Mike and Will, but unintentionally, of course, but you have to wait now until I'm finished. The very same thing happens or can happen in TCP-based protocols on the transport layer, but also still in Quic and HTTP3 because we're putting streaming format on top of that. That is relying on consecutive requests on segments. So the next one is the lack of content prioritization. We don't have that today. So for instance, if you have, imagine you have a live content and you have a very low network, the network is really bad. You want to prioritize newer content before old, or if you have an important speech or something, you would like to set priority for audio over video or vice versa. That's nothing that we have today. And last but not least, the high operational complexity. So if you are a service provider and you want to or have to provide all these streaming formats, as they all come with their own ecosystem of servers, encoding, client infrastructure, you have to provide a really huge infrastructure and maintain it, which of course creates a very significant operational burden and of course a financial one as well. So I'm out of the blocking line, and with that being said, I hand over to Mike to present us some solutions for these problems maybe. Thank you.
And we can show the results of the latency poll in between. So if we can pop up what the results were from the initial poll that we didn't show. So yeah, we see that, okay, 40% of the people do have support or need support for real-time communication, 50% for interactive, 37% for legacy live, and for 30% for VOD. So the focus of this group here of the audience is mostly on live. And there is a huge need for all of the different latencies here that we have. Okay, thank you for that. Okay, now over to Mike.
All right, so how are we trying to solve this? Like everybody else, I'm going to try and go through this relatively quickly in the hopes that we can get to maybe some of the questions. But the basics are that there's a working group at the IETF, the Media over Quic working group, developing protocols to solve this problem. And there are really two components to that. There's the Media over Quic transport protocol. And then on top of that are layered streaming formats. So the Media over Quic transport protocol is the main focus of the working group right now. And that's because this is the generic protocol meant to be run by a network of fan-out relays. So think HTTP and CDNs. Media over Quic transport is designed to be generic in a similar way and be run by networks that can carry any kind of content. So Media over Quic transport is designed also to be not only for distribution, but also contribution. So you don't need to convert from one protocol to another just to get that fan-out capacity. The primary abstractions we'll get into in a minute, but the Media over Quic transport layers, basically that generic relay supporting layer. On top of that, we layer streaming formats. And the IETF Media over Quic working group will be defining at least one streaming format within the working group, and there'll be an IETF spec for that. The streaming formats define things like your catalog format, essentially analogous to manifests in HLS or Dash, what type of media packaging you would use, additional features like timeline tracks, and potentially other mappings of other types of data to Media over Quic transport. So I saw a question earlier about, using fragmented MP4 and CMAF. A streaming format would describe, use fragmented MP4. Here's how to do it. Here's how that maps onto Media over Quic transport. I think we have a poll that we can run about the types of things that people would like to use Media over Quic transport for.
Yeah, exactly. There is a poll. So Jinsoon, if you could just bring it up. the poll about the media over quick workloads. Back to you, Mike.
Yes, thank you. So the IETF is working on one or more streaming formats, and we'll talk more about those efforts. But it doesn't need to only be the IETF working group working at this layer. So the idea is that the media over quick transport protocol is generic and can kind of be defined for relays to run. And that hopefully, once we get that finished, we'll not need to change very often because it will be generic enough to handle all these different types of data that people want to send. But the streaming formats may change more frequently as there are innovations in streaming technology, new codecs, new approaches to packaging, new use cases. So this is where custom application-specific formats could be developed, even proprietary formats. It's a separate layer, so it's not intertwined with media over quick transport. And other standards bodies, even SVTA or Dash, could define streaming formats, for other types of content as well. So metaverse standards. Let's see, can we get the results of this poll? Yeah, so most people want to do media, but there's definitely interest in logs, text chat, gameplay. So a lot of these things are kind of alongside your media, and that makes sense. You can use the same protocol to deliver other things as well. I could also see it being used for like sensor data for drones, for example. So there's a wide variety of things that you can do with media over quick transport. So let's get into it. Where's this sit in the stack? So at the bottom layer, we've got kind of the physical layer that makes up the networks that we use today. And on top of that, IP, the internet. There's kind of a bifurcation of UDP and TCP. And we have kind of traditional HLS dash streaming happens on top of that HTTPS, H1, H2 layer on the right. But now we have this new world on the left where we have Quic as a new protocol that allows for multiplexing streams. So that head of line blocking issue that Tobias was talking about, Quic allows you to alleviate that by having multiple streams in the same connection that are independently reliably delivered and ordered. And so you can, if you know how you want to map things like media onto that, you can get better latency characteristics. And so in order to get access to that, we can either have our protocol run directly over raw Quic, or if we want to run in the web browser, we can take advantage of another new protocol called WebTransport, which is kind of a successor to WebSockets in that it is initiated with an HTTP connection, and then it becomes more of a generic transport protocol. And so WebTransport gives you access to quick semantics in the browser, and we can use that for media over quick transport as well. So what does it look like to start a session? First, at the Quic layer, there's a three-way handshake. So rather than just doing like traditional H1 or H2 traffic, where you have a TCP connection that has to be opened, and then you have to do TLS on top of that, Quic saves some round trips and manages to get TLS 1.3 started as part of the transport layer. So it's very efficient in that respect, and everything is encrypted. So once you've established a Quic session, you can then establish a web transport session. I'm going to assume from here on out that we're kind of operating in the context of using media over quick transport with a browser as one of the actors. So to initiate a web transport connection, you make an extended HTTP connect request, and it essentially upgrades into a web transport session. When you have a web transport session, then you open a bidirectional stream, and that is used for all the media over quick transport control messages. So first, a client sends a client setup message, which includes the supported media over quick transport versions and some setup parameters. as required by those versions and additional parameters as an extension point. The server then responds with the selected version or rejects the connection if it doesn't support any of the client's versions. So as a sequence diagram, you can see a client setup message. We're sending versions. One of the most important parameters that we send is the role parameter. So client and server relationships are decoupled from whether you are a publisher or a subscriber. So when you initiate a connection, you might be the client of that connection, and then you can say whether you are a publisher or a subscriber or both. And if you are a publisher, you'll want to include a max subscribe ID, and that places a limit on the total number of subscriptions that you'll accept for that session. And again, there are optional extensions. So these additional parameters are a point where there could be other specifications that extend media over quick transport with additional features and functionality. What's that look like on the wire? It's encoded as a varint for the type of message, a length, the number of supported versions, the versions, additional parameters, setup parameters, etc. The server then responds. Similarly, it selects a role and negotiates a version. Looks like that on wire. Then we want to receive some objects. So first, what is the media over quick transport object data model? Everything is delivered as objects, and objects are essentially the smallest addressable units of data that we have. Those objects are organized into groups, which represent join points. So if you are joining a stream, you'll want to have useful data at the start of that. For video, that would be an iframe, an IDR frame, something that you can actually decode and make use of. And so you want to know where those points in the stream are that are good points to join. And we represent that in a way that the relays can be aware of join points, even if they don't know anything else about the payload. The payload is otherwise opaque, except for the fact that it's organized into groups of objects. Those groups are then put together as members of tracks, and the track is what you subscribe to or fetch. Track namespaces and track names used to be represented as strings. Now in drafts beyond draft 06, we're on draft 07 right now, we represent that as a tuple of tuples. So essentially you have a length with the number of elements, and then each element is a series of bytes with a length at the start. And this allows you to, instead of having to parse strings to figure out path separators or things like that, you can kind of select on different components of the namespace, and we'll get into some of the reasons why that's useful. Okay, so to get media, there's basically two things you can do. You can subscribe to it, or you can fetch it. And subscribe is our basic push-based protocol, and this is the first thing that we spec'd, and it's very useful for live. It basically gives you new objects as they arrive. And fetch is the mechanism that we use for pulling. It's similar to an HTTP GET, and that allows you to get objects from the past. So what does this look like? So here is a subscribe message on wire. Importantly, you have a track namespace and a track name, and you can prioritize this subscription relative to other things that you also have going. There's also a group order, which is another prioritization mechanism, and a filter type, which allows you to select which objects you receive. So currently, you can receive just the latest object going forward, or you can receive the current group, and going forward from there, you can also set an end to a range that you wish to subscribe to. And then when you make this subscribe request on the bidirectional control message channel, the publisher will then reply you'll note that these names are now subscriber and publisher. It's independent of client server roles, but the publisher replies with a subscribe OK. And then on separate streams, you'll receive the objects. So for example, one mode of receiving the objects is using subgroups, which we'll touch on in a minute. In that case, you would receive on a new Quic stream a header for the subgroup, and then each of the objects in series. Fetch is similar. So you have a track namespace and a track. Fetch, you're importantly wanting to address specific groups and objects at some point in the past. So you've got a start group, start object, end group, end object, and you make that request for a range of objects, and then you get a fetch OK, and all of those objects come back together on one stream. All right, hand off to Will.
Right, thank you very much, Mike. My name's Will. I work at Akamai, and I work along with Mike at the IETF in the Media over Quic working group. And what I want to do in my section is brief you on some of the latest updates. So to be clear, MoQ is not a complete standard. It is right in the middle of development. Work's been underway for over a year, and it has at least another year to go. So we are in the middle. So I'm giving you updates because every month or so, new features are added and things change. Peeps. What do peeps have to do? So peep was a word that was intentionally obfuscating what was otherwise a complex abstraction. And it's now been renamed subgroups. And that's probably a better indication of what it is. So firstly, a subgroup is a sequence of one or more objects in the same group in ascending order. So it's a sequence of objects within a group. The unique thing about them is that they have a dependency and a priority relationship, such that if I transmit them on a single Quic stream, they will preserve that relationship, because Quic streams have the feature that they deliver objects reliably and in order. So we want to signal in the protocol objects that naturally go together in order. And in media, we have a very clear application for this, which is GOPs, or groups of pictures. I have an I frame at the start, and I have P frames and maybe some B frames that follow that. But those P's and B's are dependent on that initial I frame, right? And there's an order that I need these objects arrived in. Otherwise, they are not useful to me. So a GOP is a very natural payload object that I might want to put within a subgroup. So in my first track, so the upper layer there, I've got group 0, subgroup 0, object 0, and I put them all inside one Quic stream and send that subgroup. And then I have a new group. Again, it's got a single subgroup called group 0. In the two tracks below are an example of an SVC architecture, which we want to enable. In this case, there's temporal layers. So I might have 15 frames per second in my base layer and an additional 15 or a 30-second layered enhancement layer to get me up to 30 seconds. In this case, I could happily decode the base layer by itself. And in fact, I want that to be the case. I'm willing to drop my enhancement layer. So I'll set my base layer, which is that Quic stream with subgroup 0. And notice it doesn't include all the objects. I've multiplexed the objects here across the second Quic stream, which is now carrying the enhancement layer in a different subgroup. So the notion is my base layer could have a higher priority. And when it came to congestion, the relay would naturally deliver the base layer ahead of the enhancement layer. And then if bandwidth improves, it would deliver both. So subgroups are really an indication to the relay of what can you transmit inside a Quic stream. And that's how you should think of them. Another topic that's been quite contentious and in fact remains that way is priorities, right? So there's been danger. We look what happened with H2 priorities. It was overly complex, never got used. There's been a big retraction for H3. So MoQ is trying to strike a balance between the two. So why do we need priority? We need priority if there's congestion, right? If there's lots of bandwidth and your bandwidth exceeds your payload encoded bitrate, you don't need priorities. You just send everything you have and there's no problem. But the real world doesn't work like that. At some point, the relay is going to have more data coming in that it can send out, and that data is going to queue up. So priorities are all about resolving that queue. If I've got a bunch of objects that have piled up which ones do I send first? So priority for us is a number between 0 and 255. 0 is the highest priority. I don't personally like that. I argued against it, but 0 is highest, 255 is lowest. And just the week or two ago, we published a new algorithm for how to resolve it. And basically, your subscriber, when they're subscribing to a track, they can indicate what's their highest priority, right? The publisher can also indicate a priority, and then we have other aspects. So number one, we go with the subscriber priority first. Then we go break the tie with a publisher priority. After that, we look at group order. And after that, we look at subgroup ID. So I have a little example here. It might take a little while to understand it, but don't worry, it's relatively simple. I got 3 different tracks that are being sent. The green one, the subscriber has given the highest priority to, an equally high priority as the blue track, and then the red track is the lowest priority from the subscriber's point of view. So which object would we send first if these were all in our bin? Well, we go with subscriber priority highest, and then we go with basically the priority that is the highest priority but the lowest priority number, which is priority 1, okay? So we would send this object first. After that, we would go, because this is priority 2, then priority 3, then priority 4. Those are pretty clear. But now we get to priority 5, and if you look carefully, you'll see that there's priority 5 in the green, but also in the blue. So the relay at this point has 2 objects with priority 5, and we say we break it by group order. In this case, we're going with the lowest group order first, so we would actually go off and send this object next. This continues. Now we switch up to the green because it's priority 5, and then we go back for group order in our blue track, 8 and 9. 10, we jump back to green because we're at priority 6 right now, and 7 and 8. And now we have a choice between the rest of the blue and the red. But again, we go with the higher subscriber priority, which is why we then fill in the enhancement layer on our blue track. And only once all that is sent, now we send our red track. But we do it in highest priority first. And in this case, and I just did this as an example, the publisher has given higher priority to the newer objects. So we would do 97 first, then 98, 99, and then 100. So there's a lot of complexity in how we might want to drain these, and it's there to accommodate different use cases. In most cases, you're going to have plenty of bandwidth, and there will be no congestion, and priority will never actually be used. But it's important to walk through those cases where we need it. Another new feature that didn't exist a month ago is, 2 months ago, subscribe announces. So this is really a mechanism for namespace discovery. Mike mentioned that our naming is based on a namespace and then a name, right? And the name is unique within that namespace. And this allows subscribers to subscribe to announcements of tracks instead of the tracks themselves. And when you subscribe to the announcement, you will get all the announcements that happened in the past, plus any new ones that come in the future that match your request. It does also require the client to know the actual track name through some other means, right? This only gives you the namespace, which is insufficient for subscribing to a track. So in the image, you got on the left 4 publishers, color-coded, 1, 2, 3, 4, and they're announcing different things. And I just showed the tuples. So the namespace is example, comma, as the first element, meeting 1, and then pub 1, and example, meeting 1, pub 2, etc. On the right-hand side, I show you what would happen if a client does a subscribe announce in the first case, for example, comma, meeting 1. So what they're going to get is all the announces that match that, which is the ones for which there's an exact byte match for the elements that you've specified, which is example and meeting 1. In example 2 below that, with subscribe announce just example, I'm now going to get all 4 of them because all 4 of them had example in that first element. If I subscribe in number 3, subscribe announce logs, even though logs is the second element for publisher 4, it doesn't match what is the first element in the tuple. So it's just going to sit there and wait for somebody to actually announce something that begins with logs. And then on the last one, example, comma, meeting 1, I subscribe announce that, which is perfectly fine. but then I follow it with a broader subscribe called with example, right? So that's nested. That's not allowed, and you're going to get an error back saying that your announcers overlap one another. So announcer is interesting. Even if we have a catalog-based system, we can reserve a name for the catalog. And in case, if you look at Warp, we've called it lowercase catalog. So by subscribing announce, you would then be able to request the catalog track for a broadcast, and that would give you detailed information about all the elements that were there. On another subject, joining a live stream. So you've got this flow of data coming down, and we show segments coming from left to right with time. The dark green is your group boundary, and it's like group 1, object 0, etc. And we're asking for something in the middle of an object. And it's almost always going to be like that. You're never going to conveniently ask for something at an object boundary. So if you want to subscribe to this, and say you're a client, the current subscription definition gives you the current group and all objects forward. So it'll give you 2.0, a little bit of 2.1, and then it'll carry on giving you everything into the future. But many clients want a little more buffer when they start, right? They might want 1 GOPS worth of buffer. In other words, they want to start at object 1.0. So the way you do that with MoQ is you would first do your subscribe. The subscribe would return with a subscribe OK response that indicates that group 2 object 0 is the object it's going to start with. And you would then be able to fill that in with a fetch. So you would do a separate fetch after your subscribe that will give you your starting content. And you need to decode and render your starting content first, and then add in that subscription content afterwards. So this is how we join a live stream if we want anything other than the latest from the latest group. And with existing eyes, if we look at a time diagram, time going down from the top to the bottom, you subscribe, you get a subscribe OK, you do the fetch. We notice that it takes 2 RTTs before you get your first bytes. Now, if you're Germany to Germany, that's only 40 milliseconds, right? But if you're in Australia, as we saw, we're now looking at 400, 500 milliseconds before we get our first byte back. And we would like to improve that in the MoQ world. So there's a proposal that just came out last week in Dublin, or the week before last, sorry, to update fetch to accept an existing subscription. So what we want to do is atomically and very conveniently have the relay execute that fetch for us. But by sending both instructions at the same time, we can speed it up. So all we need to do in our fetch is give a reference to the prior subscription. So we give it a subscription ID, and then we tell it how far back from live we want to join in terms of groups. So in the timeline diagram, on the left is exactly what we had before with our 2 RTT start. On the right now, we do this new subscribe plus fetch, okay? And we're basically saying I want to join 3 segments behind. It'll give us a subscribe okay, but it will immediately start returning that fetch-based content. And this reduces our start time to 1 RTT, which difficult to get it even lower than that. And it can speed it up. So if you're on a super fast connection to local, it's not going to make much difference. But for many other clients, we can remove an RTT from the start time. We also introduced a new method called switch. I'm using slides from Gwendal Simon, so thank you for that. Again, we've got this problem. If I'm a client and I want to do something like ABR, I've got different tracks at different bit rates, and I want to switch smoothly between them. I can encode those tracks so that the group boundaries represent aligned, temporary line boundaries. Those switch points that are synchronized, just like we have with adaptive media in HLS or Dash World. So in the case with the top diagram shows a case where the relay is subscribing to the black objects, which is UHD, and then it wants to switch to HD. So we would execute the switch command, and the relay would stop the one subscription, know the point at which it happened, and then start the new one at the same point. So it could smoothly align these 2 tracks of data using group numbers, which is tricky to do if you're trying to do it from Australia to Germany. And if the group, you're 200 milliseconds away, but new objects are arriving every 33 milliseconds. It's very hard to get that splice point to be clean. But switch is an opportunity to make a clean switch and have it executed on the server. The API looks like this. You basically give a subscription ID, a new track name, a track alias, and auth info. And then you'll either get a subscribe OK for the new subscription or a subscribe error. And there are some assumptions with switch that we should acknowledge, that the switch must be preceded by a subscription. It's going to occur at the first object at the next group boundary. Your groups must be time synchronized, as I mentioned, and the namespace must be consistent. And just a note, switch was presented at Dublin. The chairs asked for additional evidence that it's necessary. They want to know if you can use clever priorities to try to get past some of the difficulty of remotely joining these streams. And the onus is on Gwendol and myself to provide that information. So that's where we are with switch. But I think we will prevail. We just need to show the right use case on which switch makes sense. Also, there was a design team set out. Originally, we released a document called a catalog, and it defined a JSON-based catalog being a list of tracks. If you think of it as a Dash manifest or an HLS playlist, it's very similar in its intent and in some cases in its content. But this content design team said the catalog should not be the basis of interop for MoQ. What we really want, we should focus our interop on a media streaming format. We want a format that will play everywhere. We want to play media and have it work on all the relays that different people are building. And we want players to be able to talk to publishers that they know nothing about and still be able to receive content. For that, we need a standard media streaming format. So we have a placeholder. It's called Warp. There's a call out now for the working group to adopt the Warp draft as the beginning of the streaming format interop. And this Warp draft, you see in the diagram, references a packaging format and maybe a content protection format. It does not reference CMAF directly because there's a little issue in IETF of referencing ISO documents. But Warp can be designed to be extensible. So another streaming format can extend Warp, basically add in some new packaging, and that's where we will add in CMAF or DRM if you need it. But the core interop point will be WARF, and I'll use a packaging format called low overhead container that's designed to be very efficient for encapsulating our media. So we had a PR. This is too much text for this talk. I won't go into it. We basically, we put the catalog back into the Warp spec, and in so doing, we removed some of its complexity. So on the right is a catalog for a stream. And I think if you're in the media space, it's super obvious what this is. I've got two tracks, one called video, one called audio, and they've got attributes. And I could, as a player, know how to subscribe. I've got the name and the namespace, and that's all I need to issue a subscription for this content. Obviously, there's more complexity to it than that. That's one example, but we're on our way. Now, as a media interop point, we're also debating what features should it have. These are the features I think it should have. It should play certain video codecs. It should have a catalog, a timeline track. It should support some type of tokens. It should support events. It should support captions and subtitles, preferably WebDTT and IMSC. It needs support real-time latency, interactive, and VOD. It should support some type of content encryption and must do ABR, and it should be able to do advertising. Now, there's others who say, whoa, that's too much. You can't do everything at once. So I agree. We can't. I want to build a beautiful house with this. And what we need to build now is a foundation upon which we can build our beautiful house. I don't want to build a foundation on which we can't add things later. So obviously, we need to start with super basic things. But I think the Meteora point should at least demonstrate these 11 features if we want it to be meaningful in modern media delivery. This is not concluded, it's just opinion at this point. So there were some recommendations. We got approval to merge two packaging containers, low overhead and WCP from Meta. There's another proposal called MoQ. It's a lightweight streaming format. We can merge that in with Warp. And then we're looking at adopting what I'm calling Warp Me, just as a placeholder name, and then start defining what we want for media interop. So a lot of the focus has been on the core transport right now, but we're starting to climb out of that hole and work towards the point where we can look at trying to stream audio and video. Okay, it's always good to be honest about challenges. MoQ is not just an answer to everything without blockers. Some networks block Quic today. Quic is currently more CPU intensive until we get it into the hardware, completely into the hardware layer. We haven't proven congestion response. We haven't proven ABR. We haven't proven ads. And for many of you, WebRTC and Dash work just fine. And that's okay. You should never at some point think that MoQ is forcing things out that are perfectly good. No, MoQ needs to earn its way into the media landscape if anybody's going to use it at all. So these are acknowledged, but I see them all as solvable engineering problems. And there are a lot of good engineers working on solving these today. Here's a timeline. It's more for later on. We have interim meetings every 2 weeks. It's open. You can join it. So are all the GitHub issues, and so are all the meetings. IETF is a very approachable organization, and maybe one as close to you in the world.
Will, just one quick question. So, because we got the question also, so could you share what kind of companies are actively participating in the MoQ standard development?
So you can look at the mailing list. Some of the biggest contributors are Google, Meta, Cisco, Akamai, Ideas with Mike, and then I don't want to leave other companies out, so I'm at strong risk of doing that. But it's a very active group. We get large attendance at the IETF meetings, but you're going to see some of the biggest names in tech quite actively involved in MoQ currently. And there's others who are waiting on the sidelines for it to settle, right? It's a very, very wavy ocean right now. It's not something you can start building a product on immediately. So people want it to calm down a bit and then start building.
But there are some big brand names behind it. So there is a lot of corporate traction. No? Okay, thank you.
Should we go straight into demos then, Alexander?
Yes, I would think so.
Okay, so just two from me and then off to Mike, who's got, I think, the really cool demos. So at Akamai, we wanted to build a little video conferencing app. Video conferencing is something we can never support on an HTTP CDN before. So we're using relay code from Meta called Moxygen. I put links to it up there, and also they have a client. So we used our Akamai Cloud Compute to host some relays, one in Chennai, Frankfurt, and Los Angeles. We hooked it up with a decentralized database called HarperDB. And then we had a bunch of clients who can then connect to us. So this is now what the interface looks like. It's all a web-based. This is running inside Chrome. So I log in and I go off. I can set my encoding information using web codecs to encode it, and I announce myself, right? This is a test tool. You wouldn't actually have a button called announce. But we've announced it, send it off to the database, and there we see that other people have announced themselves. So this client can go ahead and subscribe to that content. So Peter's coming in from Boston, Alex is coming in from Boston as well, and Subham is coming in from Bangalore. So this is not WebRTC that you're looking at. This is media over Quic running on a CDN over distributed compute. And on the next slide, I put in we all held our phones up, or we had embedded time code, because that's the best way to measure latency. And the results we got for this case study were, and remember, I'm in Zurich for this one, and the first one, 207 milliseconds, that was to Boston. Peter's showing 423, but we had routed him from Boston to Los Angeles and then over to Zurich. So he was dealing with a lot of RTT over there. And India, only 211, which is very nice. All well within that threshold of 450 milliseconds that we need to have a duplex dialogue conversation. So this is just a prototype. This is not a product. We're just testing stuff here. But so far, the early results are good. Then I wanted to look at live sports, because I'm not only interested in MoQ for real time, but I want MoQ for watching the cool stuff that we watch on the weekend. So in this case, I'm publishing from Zurich, 1080p, 30 FPS, 5 megabits per second, sort of representative sports content. I'm pushing it all the way to an edge relay in Los Angeles and then subscribing to it. And this is a hard test, because normally we would do regional-based publishing. But I want to test what happens when I go strongly international. So in this case, I'm running everything from my laptop. I got OBS. This is acting as the source encode. I've got an MP4 file that I'm provisioning as a virtual camera. Then we'll open up a web browser. We're encoding here 1080p, keyframe every 2 seconds, and a bitrate of 5 meg. And I start my encoding. And then I'm going to open up a third client. So I got one machine doing a lot of work here. Just bear that in mind. Normally, this would all be distributed. The freeze was caused by my capture software having too much stuff on the screen. So on the right, we've got playback. So this video has gone from the screen on the left, from Zurich to LA, come back, and I'm recording it. And normally as a user, right, you don't see a little rectangle. I think I drag it out here. You would see your full screen in motor racing. So again, some of the latencies just pulled with screenshots. We got 1 frame delay between the two on the right, which is what you would expect for the encode time. And then ultimately between the publish and subscribe was 636 milliseconds. But of that was a jitter or player buffer of 400 milliseconds. So we could have removed that buffer completely, but it's good to have some buffer in there. Total delay for this prototype was 667 milliseconds. I wouldn't run live sports at that level. I'd add another second to it to give myself a super nice buffer, and I could happily go out at 1.6, 1.5 seconds here at very high quality. Now over to Mike.
Thanks, Will. Yeah, so I don't have too much to show here. Hopefully we'll get to the questions soon. But as you know, I'm here from Norsk by Ideas. And we have a product that is something like a media server. We've called it a media SDK, or I think of it as like a toolkit that's programmable. Here you can see kind of our studio interface. You can drag a bunch of inputs onto this palette or onto this canvas and construct workflows. We also have a bunch of output capabilities, and we can do a bunch of things in between: ladder building, composition, etc. And what I have been working on is adding Media over Quick support to this product. So now we can do things like go from RTMP to Media over Quick. And what that looks like in code is this. We could also represent it in that studio interface and make it a drag and drop capability. But this is very early experimental. As Will mentioned, the protocol is still very much in development. We're kind of in the middle of that development, and the specs are changing frequently with wire protocol changes. So tracking that is a fair bit of work. So this is very, very experimental, and it's pinned to specific draft versions as we iterate on it. Here is an example of this in action. If I can, I don't know if I can press play on this video. I do this, does it? There we go. Okay. So here you can see this code. This is in the context of some media examples that we have for Norsk. So this sets up a connection to Norsk. So there's a gRPC API that allows us to control Norsk media. And then we ask it to create an input. So we listen for RTMP input on 1935. And then we also create a Media over Quick output. And in this case, we're acting as a client publisher. So we make an outbound connection to a Media over Quick transport server, in this case, a relay that I'm running locally, and then we publish to it. We then connect our output, we subscribe it to the input. So the media that we get from RTMP, we then put out over Media over Quick. So I'm starting up this local relay. I'm using an open source implementation, MoQ, and that runs the relay. Okay, so now that's listening. And then on the left here, you can see we're running a little script. This starts up some Docker containers. So one of them is running Norsk server. That's the media server itself. And then we also have another container that will build and run this code that you see on the right. So this SDK code will communicate over the gRPC API to Norsk media. And it will run this code. For this example, we also automate setting up a input to the RTMP input that we have. So we run another container that just runs FFmpeg with an example video that it publishes to that RTMP endpoint. So here we're now connected. So you can see once these containers start up, we started receiving the RTMP input and we sent it to our local relay as media real quick. And if we look at what's running, you can see these are our standard kind of example containers. We run coturn for some WebRTC examples in cases where we need turn. That's not actually in use here. FFmpeg is just publishing into our RTMP source here. And Norsk Media is then acting, as I said, again, a client publisher connecting to our local media over quick transport relay. And so we're using MoQ-RS here, but it could connect to other relays as well. So we've used the same code to connect to Moxgen, some of the same servers that Will was using in his demos there. We're able to publish into those as well. And there are other growing number of open source implementations as well that we can also interop with. So you can see here, because this is a relay, we've announced the namespace demo. So we've gone through the setup process, and then we've announced the namespace demo. And if we run a front end and connect to this as a client subscriber, we now see video playing back over media real quick. So this is using MoQ.js. And the streaming format is something like CMAF. It's fragmented MP4 and a JSON-based catalog. This particular demo doesn't correspond exactly to any of the current specs, but it's in process of being updated to the latest and greatest. And if we look at what's happening on the relay here, we can see that when the client subscriber connects and we connect to the demo namespace, we make a subscription request for a track named .catalog. And that .catalog track has the JSON catalog that describes the other available tracks, the actual media tracks. And when the relay receives that subscription request, it then forwards it and makes another. It now acts as a subscriber to Norsk Media, which is a publisher. So we take in a subscription and we forward that to an upstream subscription, and that allows us to transparently relay these objects. Relays can aggregate those. So relays act as fan-out nodes, and that allows us to kind of build large distribution networks. So Akamai has some demos running, and we can connect to those. All right, there's a little bit more here, but we're running short on time here, so I will cut it there.
Okay, great. Thanks a lot, Mike. That was very helpful, and good to see that it actually works here in Norsk, which is the backbone of what we do for live processing at G&L. So we are looking forward to have this capability inside, and we'll closely follow when you adopt to all the new additions of the spec. So that's really promising here. So we are at the full hour now, so we've come to the official end of the time. We will try to cover a couple of questions now as long as we can. We will follow up on all other questions afterwards, either in written form or in some additional video that we create here. So first of all, thanks to all the speakers. Thanks for all the listeners here. The official part is now over. We will now skip over to some of the questions. I think for some 5 to 10 minutes, we will try to cover some questions, and the rest will be followed up after we finish this here. Okay, thanks a lot, everybody. I'm now switching over again to the slides here. Let me check if I can go over here. Okay. So we had a couple of questions that came in advance. The first one was, what's the impact for HTTP caching and CDN delivery? And there was a second question in the live chat today. So I think this is mostly a question for Will. I tried to capture something here, but to our understanding, MoQ has included CDN cacheability from the beginning as a design objective. Perhaps you can tell us something about that.
Yeah, the quick answer here, that's what separates, one of the differentiating factors between MoQ and WebRTC. So we have to make it cacheable. However, a lot of people say, oh, you can take your HTTP cache and reuse it for MoQ. You can't really. MoQ, when you deliver objects, you have to very efficiently search that cache for temporarily related objects. So you want some type of linked list built into your cache so you know what object's coming next. It's going to be very expensive and slow to search across a cache that might have 1 million objects in it to find what is the next object, and to do that 60 times per second for every single stream that you happen to be playing. So the cache design is going to be different than the cache that is optimal for HTTP. But it's a computer science problem, and a very juicy one at that. There's no roadblocks there into building that cache. In terms of CDN token auth, we've actually proposed that the common access token, which is what Akamai is hoping people will adopt for CDN access for segmented media, can also be used for MoQ. At least that's up on the proposal. There's no reason why it can't be. We have to look at it's got all the features necessary, but I think you'll see a lot of harmonization in token access between HTTP access and MoQ-based access, at least at the CDN level.
Yeah, and also taking over parts that have been defined for other services like CMCD. I saw a demo of you, or also where you integrated CMCD with MoQ, so that's also possible.
Yeah. I did that just as an interesting aside for these new modes coming out in CMCD that don't tie you to segment requests, which means we can use them with MoQ because we just have subscriptions, right? But we can still harmonize our data. I think what's super cool with MoQ, and people haven't realized yet, is when you want to collect data from all your players, you don't need to have the player post it out to some site that's then going to fall down in the middle of your big event. Because MoQ is bidirectional. The player can just publish its analytics back to the CDN that's distributing the data. And you can use the distributor can use the CDN as the collector for these logs. And that's a very different paradigm, and one we don't have today with segmented media. We have to send our logs somewhere else, or with CMCD, we piggyback them on the requests, but now we can just collect them from the edge. I think that's quite exciting.
Okay, thank you. So another question was, what's the impact for the telco network for observability, for traffic shaping? So as we are mostly looking into Quic, practically the effect will be mostly for what Quic would be anyway. So it's not something on top of Quic that the network or the telco would see.
Right, it'll look like Quic traffic to the telco. The traffic shaping, though, is interesting because I mentioned there's a symmetry here. Clients can publish and subscribe, whereas web-based clients are typically only receiving media that they request. But your media is flowing in one direction, which is why you have such asymmetry in your home network, for example. But MoQ can allow for much more symmetrical behavior under certain circumstances. So there might need to be different shaping of traffic for MoQ-based flows.
Okay, thank you. So how interoperable is this in practice with security requirements? So this also comes back to Quic practically. So the same applies to that answer.
Yeah, it's riding on Quic. Some networks block Quic today. I had that in the challenges slide, but they won't block Quic forever. WebTransport allows a fail down to HTTP2, so it still works, even though datagrams will be curiously reliable and somewhat slower, but other than that, it'll work just fine. So I think the fact that MoQ is riding on top of Quic, and Quic is now what is powering HTTP3, that you're going to inherit all the firewall support, all the gateway support, all the network hardware. You can use all the same components to deliver MoQ. And we can build servers that deliver HTTP and MoQ side by side, right, off the same connection.
Yeah, and I think that was part of some other questions is how reusable, so how much can we reuse effort that we have put into CMAF and into the publication flow? Do we have to invent everything again? No, that's not the intention.
No, you can have, and Mike gave a demo, those, they may not have been CMAF, but they were fragmented MP4 samples, but they could just as easily been CMAF. MoQ itself is payload agnostic. It doesn't care if you're using CMAF or lower of a container or you've made up your own container. It doesn't care.
Okay, so what sort of support is needed by players, and will it become broadly available? That's a big question. It's just about transport, but so what on the player side?
So right, you have to pick your streaming format, and then you build a player that plays that streaming format. And the early ones, the beautiful thing is you can build all these players completely in JavaScript today, which is super handy for development, right? You don't need to compile anything. So web codecs plus web transport bakes you a very tasty cake when you combine it with MoQ. But you can also build native clients in iOS, in Android, in Mac OS. I know Cisco, or I've seen some native clients that they've been building also for Windows. So there are to be clear, there's very few players today. You couldn't buy one if you tried. There are some open source JavaScript solutions you can use, but you have to be very careful with the server version that they're talking to. So it's going to take a year or more, or years, until I believe there's a broad player ecosystem with defined streaming formats, defined versioning, and sort of production level interop that we would expect from streaming formats.
Yeah. Okay. And Mike, I understand you're heading a summer camp project in Montevideo that is specifically about MoQ player support, no?
That's correct. So we'll be spending the Northern Hemisphere's winter, Southern Hemisphere's summer, working on building out this player support. Yeah, we have a meeting later today, actually.
Okay, cool. So let me just finish here the questions that we received in advance. We will answer the other ones that we received during the webinar later on. So just finishing with the ones here. My interest in MoQ is for the impact on sustainability or lack thereof. So to my understanding, there is no direct intention towards sustainability within MoQ. I've not seen anything, and I don't know how it would work there. But in my view, if it succeeds in really unifying the three consumption modes and practically making it possible to use a similar infrastructure for both real-time communication and for interactive and for passive consumption, then you potentially get rid of a lot of redundant infrastructure that has potentially their peaks at different times of the day. So my assumption would be that video conferencing is more during business hours, while video consumption is more in the late evening hours, or at the peak hours in the between 8 and 10. So I think there would be a secondary effect on sustainability if we really can use the same infrastructure for these different modes. Do you have other thoughts on that, Will or Mike?
Yeah, I agree with you. There's nothing fundamental about MoQ that is going to offer an immediate win for sustainability. It's about the notion you suggested of being able to remove some of the isolated or parallel systems we have today, be able to combine them into one more efficient delivery system. So your gains come from removing, not from adding. Yeah, and the other challenge with MoQ currently, we've got more CPU coming out of Quic. So this is an openly acknowledged, and I think as more Quic gets used and as we see Quic move down to the hardware level, then that delta will go away. But that's a delta we do need to acknowledge today.
Okay, cool. Got it. So, and then that was a question when I think about media over Quic, I envision unified protocol for both contribution distribution, replacing protocols like RTMP and ZXI, leveraging in a CDN environment, delivering segments and manifests. Is that true? Yes, those are all important motivations around MoQ. So that is like a summary of what we discussed. Yeah, okay.
Yep.
And other advantages for CMAF, there is not really an advantage because MoQ is payload agnostic. It could simply deliver CMAF, so you can still use it. It's not obsolete or something like that.
Yeah, absolutely. And in fact, if we think in the beginning, the vast majority of live sports content that's not real-time media would probably be used. The idea would be to use the exact same media objects you're sending out with HLS and Dash, at least in the beginning. And there's really I see no barrier to that. In fact, the product, what I'm working on at Warp is designed to enable that. What Mike's already built can do that today.
Mm-hmm. Okay, that was the last question. So we are at the end here. Thank you very much to all the audience for listening and to tuning in here. Thanks, Tobias, Mike, and Will for your contributions here. That was really a pleasure. I'm happy that this is the last webinar for this year, so I now can concentrate and focus on Christmas. Otherwise, thank you everybody, and we will curiously follow up with what MoQ is growing into. Thank you everybody, and have a great rest of the day. Cheers. Bye bye.
Bye bye.
Bye bye.